Okay, this week we are going to work on the calculations. So get your calculators out and let's go through these. Sample question. Calculate the amount of energy, so that's in joules, of 250 grams of water while release it with water will release as it cools from 80 degrees Celsius to 20 degrees Celsius. And the specific heat of water, as we learned last week, was 4.19 joules per gram degrees Celsius. So what you should do is you should write this question out. Stop the video right now. Now, once you've written down the formula, Q equals mc delta T. We're going to write out M equals 250 grams. And that is, when we're dealing with water, that is 250 milliliters. Specific heat capacity is 4.19 joules per gram degrees Celsius. And temperature final is 20 degrees Celsius. And temperature initial is 80 degrees Celsius. So my change in temperature is TF minus TI is going to be 20 degrees Celsius minus 80 degrees Celsius is negative 60 degrees Celsius. So Q equals mc delta T. Now notice how I'm lining this up just like a math problem. I'm going to then substitute in 250 grams, and we're going to do some unit analysis here. 4.19 joules per gram degrees Celsius and negative 60 degrees Celsius. Okay, squeeze all that in. Grams are going to cancel out. Degrees Celsius is going to cancel out. I'm left with joules. So I know I've done this correctly. So I'm now going to put in my calculator 250 times 4.19 times 60. And this is going to give me negative, because we keep the negative, 62850 joules. The negative means that it is giving off heat. This is exothermic. What's cooling? From 80 to 20, so heat is being released. And if I could divide this by 1,000, I'm going to move my decimal place 1, 2, 3 places over, and I round this up to 3 significant digits, and I get negative 62.9 kilojoules as my final answer. Okay, let's try another question. Okay, sample question number 2. Determine the final temperature of 500 grams of water if you were to add my heat, symbol for heat is Q, 9, and I've got to convert this into joules. My specific heat is 4.19 joules per gram degrees Celsius. And my initial temperature is 20 degrees Celsius. Okay, so to calculate my final temperature, I've got to take the formula Q equals mc delta T and manipulate it by dividing both sides by mc. M cancels out, C cancels out. I move this over. Delta T is Q over mc. And I substitute in my 9,000 joules over 500 grams times 4.19 joules per gram degrees Celsius. Notice my gram is going to cancel out. my joules are going to cancel out. And when I invert this, 1 over 1 divided by 1 over C, I'm going to get Celsius. So I've got this correct. Okay, so 500 times uh, 500 times 4.19 is going to give me 2095. So it's going to be 9, I'm going to move it up here, 2095, 9,000 joules. Okay, um, and the joules have canceled out. Yes, and we're left with Celsius. So we're going to go now 9,000 divided by 2095. And I get 4.295 degrees Celsius. Now, this is my change in temperature. My initial temperature was 20 degrees Celsius. Let's go back to the question. Determine the final temperature of 500. If, if you were to add, I'm adding heat. So guess what? The temperature is going up, right? So that's the change in temperature. So we're going to add this to 20 degrees Celsius, and I'm going to get a final temperature final of 24 and 3 significant digits, 24.3 degrees Celsius. Sample question number 3. If you add 3,570 joules of energy to a substance, its temperature increases by 10 degrees Celsius, right? If the mass of the object is 1,510 grams, determine the specific heat capacity. Okay, Q equals mc delta T. We divide m delta T. C is equal to Q over m delta T. 3,570 joules divided by 1,510 grams and degrees Celsius. Now check it, joules per gram degrees Celsius. I've done this correctly. That's called unit analysis when I look at that's my specific heat capacity, C. What are the units? Joules per gram degrees Celsius. So I've done it correctly. So, and that's by 10. Okay, so this is 3,570 joules divided by 15,100 grams degrees Celsius. I just moved the decimal place 1 to the right because I multiplied by 10. Okay, 3,570 divided by 1,510, whoops, 3,570 divided by 1,100. I get 0. Now 3 significant digits, 0.236 joules per gram degrees Celsius. That's how much energy it takes to raise 1 gram of this substance a degree Celsius. Okay, specific heat capacity of substance can be determined using calorimeter. A calorimeter is any device used to measure quantity of thermal energy. So there it is. We were going to burn something and we're going to calculate the change in temperature, and we've got the mass, right? Mass, change in temperature, and we can figure out even how much energy we're adding to it, and that will give us our specific heat capacity. And calor just simply means heat. In Spanish, calor, muy calor, I'm very hot. And there's a meter to measure it. So during calorimetry, one assumes that any energy that is released can be detected as a change in the temperature. Heat gain equals heat lost. This is a principle of heat transfer. Sample question number 4. I am going to leave this one with you. This afternoon, we are going to work on that problem. So spend a moment, try calculating it yourself, and I will see you this afternoon.